Hello everyone, very good evening. My name is Srikanth. So I have done my MTech in Mechanical Engineering, Masters of Technology. I'm having totally 13 plus years of rich teaching experience in IITJEE and NEET sector, especially in subject of physics. So today, everyone, I am going to give a demonstration on isothermal process, okay, from thermodynamics concept, okay. Yeah. So coming to isothermal process, what generally happens? So in this process, especially the temperature remains constant. The first and the foremost thing is here in this process, the temperature always remains constant. Okay. Now, if you apply first law of thermodynamics to this process, let us see what happens here. So according to first law of thermodynamics, we can say that the net heat supplied is equal to increase in the internal energy plus work done. Okay. What is the value for internal energy? So we know very well, internal energy formula will be generally mCV into delta T. So you will be having some increase in the internal energy if you have some increase in the temperature only. Okay. But in this process, since temperature is remaining constant, that means I can say there is no change in temperature. That means initial temperature is equal to final temperature. I can say that delta T is equal to 0. And since delta T is becoming 0, I can say that delta U, that is change or increase in the internal energy or decrease in internal energy, is equal to 0. No change in temperature means there is no change in the internal energy of the system. Therefore, I can say finally, from this FLOT equation, I can say that delta Q is equal to delta U plus delta W. So what is the value of delta U stands for? It becomes actually 0 and this becomes delta W. So finally, I can say that in this isothermal process, the heat supplied is always equal to what? Work done. Whatever the amount of heat you are supplying to a system, it will be coming as it is as the work done. There is no change in the increase or in sense decrease or increase in the internal energy of the system, we can say. Now, I want to bring out the relationship for work done in this process. Okay, let us see how we can bring out the work done in this process. So generally for any system or for any process, if you want to bring out the work done, the formula will be integration of P into dV or P delta V or P into change in the volume, we can say. And we should write the limits as V1 to V2. Okay, now here we have P and V. But in this process, actually temperature is remaining constant. Okay, so I can write like this. That is nothing but PV equal to N into R into T. Okay, so what is the value of P? I am writing it as nRT divided by V. So I am writing delta W is equal to V1 to V2. What is the value of P? Tell me. I am writing it as nRT by V into I am writing it as dV. Sir, why you are writing in terms of V here? Because we have dV here. Okay. So in order to integrate with dV, we need the terms in terms of V only. If we have something like dx, we need the terms in terms of x. Okay. If we have something like dy, we need the terms in terms of y. Therefore, since we have the terms in terms of dV, I am writing the value in terms of V here. Okay. Now, what are the constants here in this case? I can say the number of moles. The number of moles of the system always remains constant, just like mass. I can say, so delta W is equal to, here N is a constant, R is a constant. And in this process, in this isothermal process, T is also remaining constant. Therefore, I can just bring all these nRT, three things outside, and I'm writing it as V1 to V2, integration of dV by V. Okay, so what is integration of, very well, integration of 1 by x dx stands for what? You can say it as log or ln x simply, but to the base e we have. Okay, so in the same way, I am integrating test to dv. Therefore, I can write this one as n rt, okay, ln of v. So limit stands for to the base e, limit stands for v1 to initial volume is v1, final volume is v2. I will draw the graphs also just within 5 to 10 minutes. Okay. Yeah, this is the case. Now, finally, So what becomes the value of work done is nothing but here I am writing NRT ln. Okay, so V of this one. So I'm writing upper limit minus I'm writing it as lower limit. So we can say log A minus log B means I can say log of A by B. I'm writing it as ln to the base E. That means we can write V2 divided by V1. Okay, so this is the work done of a isothermal process. Sir, actually we have E here. I want to convert into the base 10 natural logarithm. Then we can write like this. So 2.303, I can write this one as NRT. So log to the base 10 will be getting V2 divided by V1. This is the formula actually required to do in the examination, apply in the examination. My dear students, I hope you are understanding these things clearly. Okay, sir, actually, see in the examination, V1, V2 may not be given directly to you. V1, V2 may not be given directly to you. Okay, he will be giving sometimes initial pressure and final pressure. That means for you, P1 comma P2 values will be given. In that case, what we have to do? We know very well, according to ideal gas equation, I can say PV equal to nRT. Okay, now in this process, N is a constant, R is a constant, temperature is also a constant. Therefore, I can say PV is a constant. Therefore, I can say PV is C, I can write. That means I can say finally, your P is inversely proportional to the volume, pressure, inversely proportional to volume. Therefore, from this equation, I can write that like this. So, P1 by P2 is equal to how much? V1 by V2, V2 by V1. Okay. Okay. So here I can write this one as nRT. So V2 by V1. 3.303 nRT. I can say like this. So P1 divided by how much P2. Okay. So this is the work done in terms of pressure, initial and final pressure, and this is the work done in terms of initial volume and then final volume. So these are the work done formula of my dear students. Now, if you want to bring out the heat supplied, then what you will do? According to first order thermodynamics, just now I told delta Q is equal to how much? Delta W. Therefore, heat supplied is equal to work done. Therefore, I can write this one as nRT. So log to the base 10, I am writing it as P1 divided by P2. This is the case. This is the case. Okay. This is the formula for work done. Keep this one aside. Next, coming to slope of this process or slope of this graph. So generally, since in this process temperature is remaining constant, I can say PV equal to how much? nRT. And this they are remaining constant. I can say PV is remaining constant. I can say P is inversely proportional to the volume. And if you just draw or if you just plot a graph between pressure and volume, so pressure in terms of volume. Okay, so since P is inversely proportional to volume, I can say when volume is increasing, pressure is being reduced. Or pressure is being increasing means volume is being reduced. I can say like this. So when pressure is reducing, volume is increasing. Or we can say when volume is reducing, pressure is increasing, like that. Pressure is reducing, volume is increasing. So you will be definitely getting a graph like this, which is a perfect rectangular hyperbola. Okay, so you know very well actually, xc is equal to constant means x is inversely proportional 1 by y in the sense. So this graph has to become definitely a rectangular hyperbola for me. Rectangular hyperbola. Okay, yeah. And if you want to bring out the slope Just draw a tangent to the curve. This becomes what? This is nothing but angle theta. This is the picture. Okay. Now I want to bring out the slope value. Let us see. Very simple. What is the governing equation for this one? PV is nothing but a constant. Differentiating this equation on both sides. What I can get? So P into delta V plus V into delta P is equal to 0. Differentiation of constant is equal to 0. And this UV rule, U into V dash plus V into U dash according to the mathematics. Okay, my dear students. So P and V both are changing here. Therefore, in this process, P and V both are changing, pressure volume both are changing. Therefore, P and V will come under variables. Therefore, both we have to definitely differentiate. Okay, so here I am writing. So P into delta V plus V into delta P is equal to 0. So P into delta V is equal to minus V into delta P. Now I can write like this. Just observe. So delta P by delta V. So minus P by V. Am I right? Okay. Delta P by delta V is equal to how much? Minus P by V. Therefore, this becomes actually the slope of your graph. Very important. In the examination, he will be comparing the slopes, the gamma values, many things he will be comparing. Okay. So the slope of the isothermal process is equal to minus P by V. Okay, isothermal process minus P by V. Keep this point in the brain. And if you go for adiabatic process, the slope will be gamma times the value. Gamma into P by V. Gamma times. And since gamma is always greater than 1, adiabatic constant is always greater than 1 for any type of the gas, diatomic, monatomic, polyatomic, any type of the gas, gamma is always greater than 1. Since gamma is greater than 1, I can say the slope of adiabatic process, okay, is greater than the slope of isothermal process. That is the picture. That is the case. Okay. So this is the condition. Now, coming to isochoric process. Okay. So tell me what happens generally in isochoric process in generalized case. Isochoric process. What is isochoric process? Volume is remaining constant. Okay. So generally, we know work done for any process nothing but what? P into dV. Am I right? Okay. So nothing but V1 to V2. There is no change in the volume. There is no change in the volume. I can say definitely work done will be 0. No change in the volume. Initial volume becomes final volume. This becomes 0. What becomes the value for heat supplied? According to first law of thermodynamics, delta Q is nothing but what? Delta U plus delta W. Okay. Yeah. Next. In this process, delta W is 0. Therefore, I can write finally delta Q is equal to how much? Delta U. Therefore, I can say heat supplied in this process will be entirely utilized in increasing the internal energy of the system. Heat utilized in this process is completely utilized in increasing the internal energy of the system only. There is no work done in this process. And if you want to bring out the slope of this graph, let us see what will happen. So this is P, this becomes B. This is the origin V. Okay. Now just tell me, now volume is remaining constant. How the graph will be? This will be the graph. Since volume is remaining constant, this will become the graph. And for this graph, what becomes the slope? Very simple. Okay. This becomes the slope. So slope is equal to how much? Delta P by delta V. There is no change in volume. Therefore, it becomes 0. See, there is no change in volume. Initial volume is equal to what? Final volume only. Therefore, I can say dV is equal to V2 minus V1 is equal to how much? 0. Therefore, anything by 0 has to become definitely how much? Infinity or infinite or undefined like that. Okay. The slope of the graph, which graph it is? PV graph. Okay. For especially isochoric process has to become definitely infinite. One more important point I want to say in isothermal process. So in the isothermal process, if you want to determine, see, just drawing a line. Okay. If you want to bring out bulk modulus, bulk modulus. Bulk modulus scale. So what is the value of bulk modulus? I'm saying it as change in the pressure by volumetric strain. Net pressure change or total pressure acting on the body by volumetric strain. Therefore, I can say, I can just rearrange the terms like this for convenience. Okay. So if you just write like this, delta P by delta V into V, I can write. What is the value for delta P by delta V? Nothing but the slope of the curve. What is slope of the curve for isothermal process? Just see, minus P by V. Okay. So minus of minus P by V into how much V? Okay. So K is equal to minus minus get cancelled. VV gets cancelled. Therefore, I can say finally this becomes only P. So my dear students, remember one thing clearly. The bulk modulus for isothermal process is just P. Okay. And if you want to bring out the isothermal bulk modulus for the adiabatic process, it becomes gamma times the value of P. You can check it. And if you want to bring out compressibility, it becomes what? C is equal to 1 by K. It becomes what? 1 by P. Okay. So, okay, my dear students, I wish you all the best. Okay. So, almost nearly 10,000 students of mine were there in NITs and IITs who were settled well in advanced level, mains level. And many doctors are, they got the MBBS seats in good institutes like AIIMS and Manipal and uh, all the branches of AIIMS mostly and JIPMER. Okay. So, wishing you all the best. Thank you.